Greetings everyone, my name is Mngomezulu. I'll be taking you through a building science N2. So the book that we're going to use is for MA Pentz. So the chapter that we're going to be covering today is Centroids. So it's from page 33 to page 38 on your books. So this is lesson number 1. So the topic is centroid, which will be found on your page 35 of your books. All right. Before we proceed, I think it's very important that we understand what is the centroid. What is the centroid? So the definition goes as follows. The centroid is also regarded as the center of gravity through which the line of action of its weight always passes, no matter how the body is positioned. I think what is important here is that we take note of the first line. The centroid is also regarded as the center of gravity. So that means the center of gravity and the centroid are the same things. Now, further to that, I've drawn the cycle here. You may have a square, you may have a rectangle, you may have a cycle. But any object in building is subjected to a gravitational pull. All right. So this definition is roughly about 3 to 4 marks in the exam. All right. So let us proceed and do our example, which is example number 5.4 on page 35. So the question will go like as follows. Calculate the centroid of T-beam from 0.4 meter side horizontal. Calculate the centroid of a T-beam from 0.4 meter side horizontal. All right. Now, we are giving a T-beam here. All right. What is important is that we note how many sections is this beam made of. We have section 1, section 2. So that means the beam has 2 sections, 1 and section 2. Now we need to take note of this statement. From 0.4 meter side horizontal, where is 0.4? There is 0.4. Now, I've decided to put this direction to clearly show that we are moving from 0.4 horizontal. Horizontal is going toward this point. But also to clarify more, I've decided to turn this T-beam around because sometimes it's confusing now, because if you're looking at this, it doesn't look like a T-beam. But at least if you're turning it upside down, then you can be convinced that it is a T-beam. Then we are moving from 0.4. Now it won't be horizontal as the statement says, but it will be 0.4 side vertical if it was giving like this. But note that I was clarifying what is happening here, that you can understand it more better if it's like this. All right. Then let's go to the solution and see. Now, area 1 will be base times height. Why it's base times height? Because the formula to calculate the areas, we have to do 2 things here. We need to calculate the areas of these 2 sections. That means we have got section 1 and section 2. We need to find the area of this section and then also calculate the area of this section. So because it's a rectangle, so we will say base times height. It's a formula to calculate the area of a rectangle. It will be base times height. So what is our base? Come here. Our base will be 0.4 times the height. So this becomes your height because they are saying we are moving from 0.4 side horizontal. So this becomes your base, 0.4 becomes your base, and there you have 2. There you have 2, which is our height. So it will be, base is 0.4 times 2. 0.4 times 2. So our answer is 0.8. Remember, when you are calculating an area, you must make sure that area is always in square meters. So it's 0.8 meters square. All right, let's go and see what is happening on area number 2. Area number 2 is also a rectangle. But now, this distance is our height. This distance is our base. More clarified here. Is our base here, because they are saying we are moving from this direction toward this line. That means this becomes our base. Base is 1.2. Then our height is 0.6. Then our answer will be 0.72 meter square. Now, what I've done here is that you have area 1, area 2, then you combine these answers. 0.8 plus 0.72, you get 1.52 square meter. All right, we are done with the areas. Our second point, for us to be able to calculate the centroid, we also need to find out what is our y. What do I mean? What is our y? Our y, remember from here, I said any object is subjected to a gravitational pull, which means from approximately the center of any object to what pulling it down is the gravitational force. This gravitational force. That means it's a distance. If you're looking at here, approximately from the center pulling it down. From the center pulling it down. So we need y. What is y1? Y1 is 2. So let's go then see. Y1 is y1 divided by 2, which is approximately the half of that object. So it will be 2 divided by 2, which gives us 1. All right, I think this was more simple. Then let's go to this second section. Remember, this is building science. When we are building, the statement says build from 0.4 side horizontal. 0.4 side horizontal. Because now we are focusing on y2. Now, these two formulas are almost similar. The only difference is that when we are building, we will start from here moving up, or we'll start from here moving horizontal. It's the same thing. So because we are here, we'll say this distance approximately y of this section divided by 2, which is this. y2 divided by 2. This, you can notice this is the same as this. This is the same as this. So it will be y2 divided by 2. What is our y2? 0.6 divided by 2. Now, why are we adding y1 here? It's because when we are building, you can't reach this point unless you have passed section 1. Unless you pass section 1. That means you will have this whole section. But our focus is not here, is here. So you say 0.6 divided by 2 plus this whole section. Let me make another typical example so that maybe one might understand. Let's say you are having the third section here. That means you're going to have section 1, section 2, section 3. Now, when it comes to this y, you are going to say y1 plus, you say y1 plus y2, you get an answer. Then when you are dealing with y3, which is the section that I said, if it happened that we were adding, we'll say y3 divided by 2 plus this whole distance. because you can't reach this section unless you pass these 2 points. I think it's going to be more clear. So it's going to be 2 plus 0.6 all over 2. It gives us 2.3. Now, we're done with area 1. We're done with area 2. We're done with area Y1. We've done with Y2 as well. So let's go to Y bar. This Y bar, or the centroid, this is a sign to say we are calculating now the final answer, which is the centroid. It will be area 1 plus Y1 plus area 2 times Y2 divided by the total area. It will be area 1, which is 0.8. Area 1 is 0.8 times Y1, which is 1. Then area 2, that will say plus area 2, 0.72 plus Y2, which is 2.3, divided by 1.52. But let me clarify something here. As I said earlier on as well, that if you had a third area, which was going to be area 3 plus times Y3, you were going to keep on adding. This formula is not limited. It depends how many areas or how many sections do you have. Like here, we have only 2 sections. If it happens that we have the third one, remember, here when it comes here, you are going to keep on adding, but you divide by the area total. Right. Then the answer for this problem will be 1.62 meters. Now, we are done with our calculation, but I just want us to go back here. Calculate the centroid of T-beam. Right. What this 1.62 means. This 1.62 means. I've decided to go back and draw it in the drawing. It means when we are starting from this point is 0.4, going up, our answer, which is our Y bar, when we combine these 2 sections together, we find that our gravitational pull is somewhere there, it passes through this first section in terms of the calculation. Y bar, or the centroid, is 1.62. That means from here to here is 2. That means this Y bar, or this centroid, is within the first section. That's what I wanted to clarify. I think we've come to the end of this example. Thank you very much for your time. We will meet next time when we are doing the next problem. Thank you so much.